Okay guys, today we're going to be talking about rational expressions, specifically multiplying rational expressions. So what a rational expression is, that's a fraction whose numerator and denominator are non-zero polynomials. That is a rational expression. Alright, now over here I say let a, b, and c be non-zero real numbers or variable expressions. That can mean something like this. If I had like ab over ac, how would that simplify? Well, that would simplify simply to be BC, right? Because the A's would be in common. That's the symbolic or the variable representation for what we're going to be working on today. So let's look at some of these examples we have below. 20y over 4. How do we simplify a rational expression? Well, we want to think about what terms they have in common. 20 and 4 are my integer portion of this rational expression. I'm going to rewrite 20 just for this problem. 20 is the same as saying 4 times 5. Agree? So my numerator, I'm going to rewrite my numerator as 4 times 5 times y. Okay? It's all attached to multiplication, which we'll mention in a second is very important. Notice we have a 4 on the top and a 4 on the bottom. If I had the same thing top and bottom, we could just cancel them right out. We would get 5y. This is my final answer, 5y, for this first problem. Some of you might be saying, well, Preddy, do I really need to write 4 times 5 because I know 20 divided by 4 is 5? Yeah, this is probably extra detail, maybe a little overkill. However, it's there to emphasize a point that we're looking for common factors between the numerator and denominator in order to simplify. 20 and 4 had that common factor of 4. And that's what allows us to divide it out or cancel it out. This second one's very, very important for us. This is an example to illustrate something that we are not, emphasis on not allowed to do. Right? X over x. Well, x's cancel out, right? So my answer is negative 4. No, that's a big no on that one. Okay? You cannot, emphasis on cannot, try to cancel things out like this, where we can cross out something from the numerator and the denominator if it is attached through addition or subtraction. Say that again. You cannot cross cancel out like this if it is attached to addition and subtraction. Only when we're attached to multiplication can we do that. So this is not the same as saying it equals negative 4. In fact, we would not be able to simplify that fraction. It would just stay x minus 4 over x. Okay? My third one. This one is attached to multiplication. 8 times x, 24 times x to the third. So now we look to simplify as well. Now I'm not going to write out all the terms this time. So let's just think about how we can cancel. 8 simplifies to 24. 8 over 24 is 1/3. 8 goes into 24 3 times. X over x to the third. Alright? That's really like saying, if I do my little side work, that's like saying an x over 3 x's, x to the third. This numerator x cancels out just one of the x's on the bottom. So I'm left with 2 x's or x squared, x times x, x squared. You'd also remember your quotient property, that this has a 1 right here. 1 minus 3 is negative 2, and that's why we have x squared in the denominator. My last example on simplifying. This example has problems with addition and subtraction. So we just said we can't cancel things out. I can't go x squared, cancel out x squared. Can't do that. But we can rewrite this into a multiplication problem. How? Well, through the skill that I said is the most important takeaway from Algebra 2, factoring. You gotta be able to factor. So we're gonna factor our top and bottom. Remember in factoring, now this isn't a factoring lesson, but you might want to review your factoring notes and examples. Factoring, we look for something that multiplies to c, so something that multiplies a negative 2 and adds to the b term, in this case 1. So we want to find something that multiplies a negative 2 and adds the 1. Well, something that multiplies a negative 2 and adds the 1, that combination is 2 and negative 1. This is my numerator in factored form. My denominator in factored form, something that multiplies a negative 3 and adds the 2. That would be positive 3 and negative 1. That's my numerator and my denominator in factored form. Now, hopefully it's clear to see, well, what we can cancel out. I have x plus 2 times x minus 1, so that's attached to multiplication. And I have the same term on the top and bottom, leaving us with x plus 2 over x plus 3. So when we have expressions like these, it's important for us to factor first and then look to simplify. Well, so, now this is just to multiply numerators and denominators. So you can fill this in as like a over b times, I will do this, we'll put b over c. So this would equal ab times bc, because we just multiply straight across. And you might even notice, involved in multiplying, we might be doing some canceling out as well, some simplifying. Here are the steps. All right, you're gonna want to reread these steps to yourself. Factor all numerators and denominators completely. Divide out common factors of any numerators and denominators. They do not have to be in the same fraction. We can cancel out diagonally as well. Okay. We're gonna multiply numerators, multiply denominators, and be sure the numerator and denominator have no common factors other than 1. Basically, that last step means, hey, make sure you look to simplify as much as possible. All right. So let's look at this next example. Now, there is more than one way. So if you're pausing your video and trying to solve along with me, which is highly recommended, there is more than one way of solving. There's only going to be one solution, but there's more than one method because you can choose to cancel things out in a different order. It doesn't matter. For this particular problem, let's emphasize the cross cancellation. 6 is a factor of 12. 6 goes into 12 2 times. 3 and 9. 3 is a factor of 9. 3 goes into 9 3 times. Now, I can keep canceling from here, but I'm a person that if I start having too many things crossed out, it starts to get a little overwhelming. I don't want to lose any of my terms, so I'm going to rewrite my problem now. I can multiply y squared times 3 times y cubed. That's 3y to the 5th. I'm multiplying straight across the numerator. We get y to the 5th because we add the exponents for these y terms. In multiplication, we add the exponents. Y times 2 times y to the 6th is 2y to the 7th. Now I have a singular fraction, but I still have work that I can simplify. Specifically, I can simplify these y terms. Y to the 5th over y to the 7th. Well, this would cancel out 5 of those y to the 7ths, so leaving us with 2 left over. So my final answer would be 3 over 2y squared. Now, this is my final answer because my numerator and my denominator do not have any other common factors besides 1. 3 and 2 have nothing in common. Y squared has nothing in common. That's why that is my final simplified answer. All right. Our next one, multiply. Now, multiplying can get a little fun because you start figuring out some patterns in order to simplify. So, looking at this problem, I already have my eye out on a couple things. For example, 3x plus 15. Well, I'm going to try to factor that before I even rewrite it. Well, how can I factor that? They have a GCF. Let's factor out the GCF. We can write that as x plus 5. X squared minus 25. We can factor that as well. That's a difference of 2 squares. X squared is a perfect square. 25 is a perfect square. Difference of squares is x minus 5 and then x plus 5. And that's how we do the difference of squares, right? Square root of x squared is x and x. Square root of 25, 5 and 5, 1 plus, 1 minus. All over x. Now we look to do that cross cancellation again. Well, x plus 5 cancels out x plus 5. X will cancel out x. Now, I have nothing left to cancel out, so let's rewrite this. 4 times x minus 5 over 3. I take one last check to make sure that these terms have nothing in common. They have nothing in common with one another, so therefore that's my final simplified form. Like I said, they can get a little fun because you start finding patterns like, oh, hey, this is definitely going to have an x plus 5 in it. That's going to have x plus 5. So you almost start like seeing these cancelizations before they happen. Now, I'm going to multiply one more time. And I am going to look to factor and simplify as well. This one's going to require us to do a little fancy trick, but I'll show you what it is in a second. First, let's rewrite this underneath, and let's write it in factored form. X squared minus 2x minus 15. I need a factor of negative 15, or factors of negative 15, that add up to negative 2. Well, that's negative 5 and positive 3. Negative 5 times 3 makes negative 15. Negative 5 plus 3 makes negative 2. Times 4 times 5 minus x. I'm going to put over 1 just so we have a denominator on that side as well. Now, looking at this problem, I don't have anything in common to cancel out right now. But you might be thinking to yourself, well, man, Preddy, that one's pretty close to this one, right? X minus 5, 5 minus x, they're kind of close. You're right, they're kind of close, but they're not the same. Right? They're kind of close, but they're not the same. Can we make them be the same? And that's the trick. We absolutely can. This left-hand side, we're going to leave it exactly the way it is. I'm going to be rewriting the right-hand side. I want to make this 5 minus x to be the same as that. Look at the terms individually. This is a minus 5, well, that's a positive 5. This is a positive x, well, that's a minus x. So they're very close to one another. They're just opposite signs. How do you change the sign of something? You can multiply or divide by negative 1. If I divide by negative 1, or, in other words, factor out a negative 1. So I'm going to divide everything by negative 1. Well, if I divide everything by negative 1, that would change the sign. Right? That changed the sign of everything. Now, those are the same. We can cancel each other out, leaving us with negative 4x over x plus 3. Recall, we cannot cancel out this x and this x. This is attached to attached to addition. We can only cancel if it's attached to multiplication. All right, that's our final answer. I know that divide by negative 1 is a little kind of a weird trick there, but that's if you ever had a situation where you have basically the same terms but opposite signs, we can divide by negative 1s to make them match. Your practice tonight is just on your own page. All right, 4 problems. This is what I expect you to work on, upload, submit, and all that. Okay? Message me if you guys have any questions.